The Lake Huron Technical Committee was charged by the Lake Huron Committee with the task to review lake trout progress towards rehabilitation relative to the milestones set out in this, the 1998 Lake Trout Rehabilitation Guide. To get started, it is important to understand the theoretical progression that was expected for lake trout rehabilitation efforts. This is a graphic of the expected timeline for a single cohort of lake trout stocked, and then the echo of wild fish from that cohort. It is plotted with abundance on the vertical axis and time in years on the horizontal. As we follow the purple line from left to right, we see fish start to become vulnerable to sampling gear and fisheries at about age 2. Increase in representation as they recruit to the gear and then decline through mortality. We subsequently see the wild progeny of these fish, depicted in the yellow line, start to appear at about 7 years after this, or 8 years after the first year of stocking. Their representation grows in a similar pattern as they recruit to sampling and fishing gear, and then declines again through mortality. In the 1998 Rehabilitation Guide, milestones were separated based on this expected progression following stocking and were grouped into two main temporal categories, Phase 1 and Phase 2. The first of these was to occur 7 to 12 years after initial stocking, based on the timeline I just showed. Progress was to be described using these three elements: mean age, adult abundance on spawning reefs, and wild juvenile abundance presumably resulted from the successful spawning of those adults. Following the initial phase, the second phase would take place some 14 to 24 years after stocking and would have the same three elements. However, the population would then be expected to be made up either primarily or at least contain a significant component of wild or unclipped lake trout. At this time, mean age of adult fish would be 3 to 4 years older than first age at maturity, and wild fish would form the bulk of spawning fish, and juvenile recruitment would persist at the same level based on the spawning success of those wild adults, and the population would be effectively self-sustaining at this time. There was a third category of milestone from the Rehabilitation Guide that described improved survival of lake trout eggs to yearlings. Though this factor seemed to have been critical to improved recruitment of lake trout through the ecological changes from Dreissenid mussel invasion, there is really no direct measurement of egg to yearling survival for Lake Huron. That fundamental change seems to have been the virtual elimination of alewife, which would simultaneously have reduced thiamine deficiency syndrome as well as any fry predation that may have been occurring when alewife were abundant. Whatever the mechanism, wild recruitment of lake trout improved in many places throughout Lake Huron in the mid-2000s. Since there's no data on egg survival available, I will not address this milestone further and will focus on the other three metrics. Now, this is a busy table, but the only real point I make here is that 5 agencies have contributed to this summary, which represents massive efforts by countless workers and financial investments over decades of surveys and thousands of gear efforts and tens of thousands of fish samples. I will note that there is a consistent approach of targeted spawner surveys and another of non-spawning surveys to assess recruitment from the agencies that were involved. Aside from this general consistency, however, the surveys were not specifically standardized. The Lake Trout Working Group did settle on setting standard mesh sizes to be used for comparable surveys, as well as a consistent size of 532 millimeters, or about 21 inches of total length, that would determine adult-sized fish. So fish larger than this were considered adults. Mesh sizes to be used were 102 millimeters and up, or 4 inches, for spawner surveys, and 51 to 102 millimeters stretch mesh for juvenile surveys. The following slides, I will present a summary of the results from each metric by agency. Most of the plots I'm going to show are set up in a similar way. Most plots are time series, which show the trends in the metric being evaluated through time. Most will show a line for both clipped or stocked fish, shown in purple here, as well as the wild or unclipped progeny, shown in gold. My colleague Trent Francis, who generated most of these plots for me, is a Minnesota Vikings fan, so you will have to tolerate his choice of colors throughout the presentation. As both the early time frame and later time frame use the same metrics, we have plotted them on a single plot. You can therefore interpret the time frame 1 using the purple chart elements and time frame 2 using the gold lines. We have also shown the target lines in the plots to make it easier to see if the milestones have been met. The initial target for milestone 1 is 1 year older than the first age at maturity, which the Lake Trout Working Group set at age 7, as female age at first maturity is around 6. For the second milestone, the ages were wild fish greater than 9.5 years on average in the northern Main Basin and 8.5 years elsewhere. These are the top 2 dotted lines. The first set of plots from the Ontario Ministry of Natural Resources Summer Gillnet Survey shows a panel for each of the northern and southern Main Basins on the left-hand side, the North Channel on the top right, and Georgian Bay on the bottom right. You can see that in virtually all cases, we have seen increases in the mean age of both clipped and wild trout in each basin. While the Main Basin has seemed to have the highest mean age, it is only exceeding the target in the southern Main Basin and then also in Georgian Bay for stocked fish. And it has not consistently reached the target for wild fish, the middle dashed line, in any of the basins. From the Michigan Department of Natural Resources spring gill netting data, we see much higher mean ages, consistently exceeding the target going back as far as the late 2000s. Clipped fish now have a mean age approaching 15 years, and wild fish are over 12 years on average. Similarly, we see a well-formed progression in mean age among lake trout sampled in the U.S. Fish and Wildlife Service spawning reef surveys, starting with clipped fish exceeding the initial threshold of 7 years in about 2000, and that group continuing to increase in mean age to over 15 years in recent surveys. Wild fish also have surpassed the secondary target of 9.5-year mean age in at least 4 of the past years of survey. U.S. Geologic Survey data from spring gill netting surveys at 6 Fathom Bank and Yankee Reef show similar patterns to that observed by the Michigan DNR. Clipfish are now consistently over the target dating back to the 2000s. However, low sample sizes for wild or unclipped fish make it difficult to determine a pattern for this group. At Drummond Island reefs, Sioux tribe spawner surveys have shown an increasing mean age which exceed the initial target by the 2005, and wild fish mean ages approaching the target of 9.5 years in more recent years. However, they still remain shy of the milestone. Moving on to spawner abundance, we have a simple milestone of spawner catch rates on spawning shoals exceeding 17 fish per 305 meters of large mesh gillnet. For the initial time frame, this would be clipped fish, and in the second time frame, would be expected to be wild spawners. In this chart showing OMNR spawning survey data separated by individual spawning populations and then organized by each basin for Ontario waters, we can see the total spawner abundance has exceeded the target in 3 of 11 surveys conducted since 2008. In none of these surveys has wild abundance exceeded the target, however it was close in the Burnt Island area in the northern Main Basin just this past fall, 2024. Michigan Department of Natural Resources spawning reef surveys have consistently found adult catch rates for wild fish to be exceeding the threshold dating back to the first surveys in the early 1990s, and now have catch rates twice the minimum threshold for the milestone. Similarly, U.S. Fish and Wildlife Service spawning reef surveys at 6 Fathom Bank and Yankee Reef now show exceptional catch rates for spawning adult lake trout exceeding 60 wild fish per net in both locations. These plots also nicely depict the expected pattern from stocking and recovery that I described previously. You can see the increase in stocked adults in the early years of the surveys, and then peaking, and then wild fish increasing in response to their presumed spawning success. This clearly shows the passage through the phases from milestones 1 through to milestone 2. Spawning reef surveys at Drummond Island by Sioux Tribe had consistently found catch rates of clipfish exceeding milestone 1B from the initial survey dates up to 2010. The results have been more variable lately. However, there appears to be a trend of increasing wild adult CPUE with the more recent surveys, now passing the phase 2 threshold. The final milestone we examined was juvenile catch per unit effort. Though the milestone only considered the wild catch per unit effort, we have plotted both stocked and wild fish to provide context of the stocked fish densities that would have resulted in the adult abundances that I just reviewed. The target minima for juvenile lake trout catches were set at 1 to 2 fish per 305 meters of gillnet. The dashed lines were set at 1 in all figures, but vertical axes will vary depending on survey and agency, as catch rates varied wildly. In this plot, we have Ontario Minister of Natural Resources data, and we can see how juvenile numbers of clipfish were very high early in the time series from stocking efforts, sometimes so high as to be 8 to 10 times the expected. Though stocked fish juvenile CPUE often exceed a minimum target, wild fish CPUEs generally remain below that, often remaining at about 0.25 to 0.5 fish per 305 meters of net. You can see, however, a pattern of stocked juveniles being reasonably replaced in the main basin of Ontario waters, particularly in the south. Aside from the most recent years in the North Channel, wild juvenile numbers remain low there and in Georgian Bay. Spring gillnet surveys by Michigan DNR have shown increasing juvenile lake trout catch rates since about 2010, and are exceeding the threshold in some years and are more consistently at or above the suggested range. Spring gillnet surveys of Yankee Reef and 6 Fathom Bank by the USGS showed very high juvenile abundances from the beginning of the survey up to 2005. These were stockfish. Recently, however, these have declined, and wild juveniles have remained rare in these surveys. Sioux Tribe summer gillnet surveys have shown juvenile lake trout catch rates, while variable, have often been near or exceeding the threshold for milestone 2C for wild fish, of 1 fish per 305 meters of net. To summarize, though the methods have varied across agencies, some common patterns emerged relative to progress for lake trout rehabilitation in Lake Huron. Most clear of these is that the U.S. waters of the main basin have shown good survival and increasing mean ages of lake trout and now exceeds the milestone thresholds in most areas. Spawner densities are also high in most U.S. waters, exceeding the minimum target for this metric as well. While juvenile densities for stockfish in the main basin had exceeded the target threshold, the densities of wild juveniles often remain below the 1998 target. Given the apparent progress based on other metrics, it is possible that target was overly optimistic. Ontario waters of the main basin, on the other hand, have met fewer of the milestones, and in fact, none of the targets through Phase 2 have been reached. Generally, preliminary, or Phase 1 milestones in the North Channel and Georgian Bay were either unmet, such as with mean age, or were only partially met, such as with the catch per unit effort for spawning fish. Catch per unit efforts of juvenile stockfish were quite high. However, it appears mortality of these fish was too high. It did not result in sustained increases in mean age and numbers of wild spawners. This is likely what has led to the lag in wild juvenile CPUE and failure to meet the target from this metric as well. Finally, I would like to thank all of the contributors to this presentation, as well as past and present field staff who have invested many hours in the assessments of lake trout restoration efforts in Lake Huron. Thanks also to the members of the Lake Trout Working Group for helping getting the data together for this presentation. And I thank you all for your time.